right, so then I get R of 0.738. What can you tell me right off the bat about that? It's positive, and it's decently strong, sure. So on the test, I'm not going to make you into like a R connoisseur, like you're not going to have to swirl the line and go, it's got hints of, no. So you have to figure out what adjective to use. So I'm going to give you either like 0.92, which is strong, or 0.27, which is weak. So not something in the middle, because I would actually say that's moderately strong. So you're like, what adjective do I use, Jeff? So on the test, I'll give you one that's very clearly one or the other. So here it's, moderately strong, decently strong, whatever. What kind of correlation? Positive. An equation for the line of best fit was like 0.66x, don't turn off, plus 70.97 roughly. You don't have to round. Oh, now what did I forget there? Why does it look like that? Good. Zoom 9. So we can tell, and I tried to make this look like, I think this group of data, I can't remember what the hell group of data I tried to make this look like. Screw it. That doesn't look like anything. I thought I did, but I guess not. But I can tell from this, it's obviously not perfect, but it's pretty good. I mean, there's no question that the flow is that way. So the 0.738 is trying to gauge that. It's not perfect, nowhere near it. But the flow is all that way, so that's why it's still decently strong. It's close to 1, closer to 1. Would I trust the line? Yes. So let's see how to actually predict something. Yes. So predict the grade for someone who studied, what you got, Jeff? 17 hours. Predict the grade, the grade for someone who studied 17 hours. Which variable would I put 17 into?
X.
Yeah, X is the number of hours, because X was the list 1. It's just like X, Y points then. So if I take my equation in my line of best fit and I throw a 17 in here, the result is going to be the predicted grade. Does everybody see that? So I can say predicted if you got 20 hours, predicted if you got 11.78 hours, right? And you just plug it in. Not a big deal, right? That's what the line of best fit is used for. Before we did this kind of analysis, our best guess was the average always. Now I've got this line of best fit that gives me a better guess based on more information. That's really what's going on here. It's kind of nifty, yes? Okay, good. I'm going to show you. Now watch this. Here's the ultimate shortcut. What are you guys getting for that? Let me catch up, and then I'm going to show you even a better shortcut than what I think you're doing. Or, a different shortcut. So if I do 0.66 times 17 plus 70.97, I predict the person would have an 82.19 grade point hours. Now if you rounded less than I did, you get more decimals in your answer, you do. Now watch. If I go back to my graph, if you hit second calc, I can calculate something graphically. Second calc, and I want to calculate a value. I want to calculate a value for 17. 82.19. Yay. I think that's sort of related to what you're doing. You're going to use the table, but then I can just use the picture. Yeah. Do you have to know how to do that? No, we got the freaking number before I showed you how to do that, but that's just a nice shortcut. Calculator costs enough money, you should be able to do that kind of shit for me. Okay. All right. Right above trace.
Okay.
So everything on this top row is related to graphing.
Okay.
So the calc means calculate something graphically. If some of you guys took further mathematics, is anything looking here familiar? Like there's the intersection between 2 points, two lines. The max and min for like finding the vertex. Remember that shit? Anybody know what number 6 and 7 are? Derivative and integral, that's calculus shit. Oh shit. Now,
I actually like that.
I love it.
I'm gonna take that next.
Calculus kicks so much ass. I want to show you this once. Guys. Alright. Guys. Oh, Peter's doing something. There's an equation for R. This is the one chapter where I think the equation doesn't really help with the idea. So I know I make you do a lot of shit by hand. I do. Oh well. It's because I believe that helps you get the idea in your head, what's going on, instead of just a button. I want to show you this equation once. You ready? You're not ready. Here's the equation for R. But can you see real quick? This doesn't look like it, but this is related to the standard deviation of the x's. This is related to the standard deviation of the y's. And this is kind of related to the standard deviation of x and y together. Why does that make sense? I'm not going to make you use this. But why does it make sense? I consider R to be sort of like a two-dimensional standard deviation. The values are different because 0 actually means no correlation, right? It's just all over the place. And 1 and -1. But it still gives me a measure of how far away from the line the points get. You guys semi with me? So obviously then it makes sense that pieces of standard deviation for all the variables showing up the equation makes sense because that's its job, is to see how far away from the line everything is. Okay. So don't worry about that. That's the most you'll have to worry about it, is me blowing it up in your face there. Bam! Okay. There was one last thing I wanted to say. We gotta get out way too early. Maybe I should do section 10 too. Oh. So I want to say just one thing about section 10.2 if you want to try that extra credit out. And then a little preview of what we're about to get into. Oh, that's what it was. Oh, you guys are going to hate me. That's too bad. Maybe I'll do this next time. Yeah, well, maybe we'll do that next time. All right. 10.2, real quick. If you do want to try 10.2 out. I don't want to say too much about this, but... All right, that's the z-score, z-star, I'll call it z-star, right? Chapter 10 says, what if I don't know shit? I don't have like a guess about what the real mean is. So I can take 2 samples and compare them. So what happens is, I'm just going to cut to the chase. Not just 1 x bar, I have 2 x bars. What's up? Is that right?
Is that a negative next to the x bar squared?
That's a minus in between.
Oh, minus. Oh,
Yeah.
Okay.
Because what is this supposed to measure then? If I have 2 samples and I'm trying to see if there's a difference, like I give these guys my new drug and I give these guys a placebo, I do want to see a difference between the 2, right? So I'm going to measure the difference between the averages of the 2 groups. But we all know that's not good enough for measuring distance. If I said is 11 close to 12, your appropriate response should be that's not enough information, right? Because if the standard deviation is 0.01, 11 and 12 are light years apart. But the standard deviation is 12, then 11 and 12 are really, really close together. Right, the 1/12th is a step apart. So I got to divide by the standard deviation now. All right, you're gonna love me. Okay, you ready? So I need to double everything because I have 2 samples now. I have 2 populations now. So somebody cool with that step there. What's the square root of sigma squared? Sigma. Okay. And now I just make room for 1, 2. Pieces of information. Every everything doubles. Okay. That's an extra credit section, but I wanted to give you a little bit of information. So step 4 in the hypothesis test, you're going to use this formula. If you want to try that section out. Yes, sir.
Oh, for section. Okay, so
10-2, yeah.
you said sigma.
What's the square root of sigma squared? Sigma.
Yeah, I'm just trying to see.
Well, what's sigma x bar? It's the sigma divided by square root of n. We know that. Yeah. And now I'm just making this one big ass square root so then I can make room for 2 because I've got 2 populations. Everything doubles. So 1 x bar, 2 x bars. 1 sigma, 2 sigmas.
So just that
1 n, 2 n's.
That formula just turns into that.
Yes.
Okay, that's
So you're like it became p hat minus p for percentages.
Yeah.
For 2 samples, it becomes this.
Okay.
That was a real quick thing. It's a credit. I'm not going to talk that much. Yes.
So where you put like the sigma second and the square root, it says the sigma number 2, it has a 1.
Yes, sigma 1 squared. So it's the first standard deviation divided by how big the first group is. Second standard deviation divided by how big the second group is.
So when you get from that equation.
Say good. So they have to tell me 2 standard deviations because this will be for the group that gets my drug and this will be the group that gets the placebo. Not necessarily, no. So it could be the standard deviation in grades for men and the standard deviation in grades for women. First group, second group, whoever you call 1 and 2. Yeah. Okay. All right. I'm dead. Let's forget about this. So we'll Monday we're gonna get into chapter 11 after that quiz on the hypothesis tests. Yes. Don't forget your stuff. Thank you.
Do you have any entries in school notes? Turn on the test script.
So I normally add that into the homework grade. So if you got like 100 homework, it would go to like 102 or something. Or it takes the place of homework you're missing or something.
Oh, really? That's perfect.
Yeah, so yes, after our study on, but that means you have to come.
Yes, I'm gonna be.
I think this one day, I was like, let's study one day. And you're like, okay.
The one day I missed.
And then you
the
don't
one
come.
day I missed.
And I'm like, this big.
That's
Bye.
crazy.
One guy left his ID on the day of the final.
Oh my goodness.
He had to come in over the summer that time and get his ID. I'm like, I don't like having this. Yes, totally. Because that's way too specific. That's specifically the first one thinks this way, and the last 3 don't. So, right? That's not what I asked. Yeah. So if you want to do it directly, it's either the first one or the second one or the third one or the fourth one or the first 2 or the last 2 or the middle 2 or the first and third or 3 of them or 3 of them. Oh my God. So what's the probability of at least 1? 1 minus the probability of, and you already figured out the probability. You just got to do 1 minus this.
Yep.
Yeah, there you go. Because that is not the answer. That's not at least 1. That is the first one, but not the last 3. Way too specific. This includes a lot more things. Yeah.
So because this equals this, and we think that this would equal this as well.
Hell no.
Yeah, see, I felt like that was a no too.
Because I mean, probability of A could be 0.2, and the probability of B could be 0.8.
But then it's like the
Right?
probability of B
I
getting
know,
A.
I know, so, like, A adjusts B, maybe it adjusts B a little bit down.
Oh.
Which means B should adjust A a little bit down from where it is, there's no way it could be the same. Yeah. So, and if you look at the equation, the tops of both of them are gonna be B and A, right? But on the bottom of the given A is A, on the bottom of the given B is B, and that's different. So that's why in this one, I asked you to figure that out, because that's gonna be on the bottom of this term. Well, what else do I tell you? Probably A or B. What's the equation for probably A or B? Probably A plus, probably B minus A and B, right? What do you know? You know this, don't you? I tell you that. You figured this out in part A, right? And I tell you this. You get it.
Oh.
So then you can solve for that algebra. Subtract, add, done.
So subtract these two.
Right. You solve for this. So you subtract that, you add this, so you look for this on the side. You can replace this with x if you want to make it really look algebra. Because that's the value you want.
So just make sure you're gonna subtract these two. and add
Yeah, you
this
gotta
to the
subtract
next.
from this side so that it cancels, right? You're gonna add that so that cancels. You're trying to get x by itself, like always. Okay.
To find the mean
Yeah, exactly. Oh, my camera's still going. It's an exciting part.